So our topic today is about flowcharting and repetition. Iteration is just another word for repetition, doing something over and over again. Very important in computing, obviously. And flowcharting is about one of the methods of representing our algorithms. And so here we've got an example that we want to use to sort of teach. Imagine that you had to create what's this? This is a emblem, and looks like a poster, right? And so we've got some emblems that we could use for the FIFA World Cup. They look like Lego emblems, right? So if you were going to do that, you might go through some steps. And so an algorithm might help you in going through the steps to come up with something like this. And so these steps here have been numbered. It's interesting that the first number is number 0. We often do that in computing, start with 0 to represent the way we do our numbers in computing, right? So the first step could be that somebody came and asked you, could you please help us to solve this problem with how we're going to make an emblem for the soccer 2022. Then the team will sit down and think about it, and they'll break into smaller blocks. The idea, you're familiar with that concept now, I hope, which is decomposition. Take the big problem, break it into smaller problems. Then you might recognize that there's some patterns. In Lego, there's patterns. So some of the blocks have 2 little notches on them. Some of the blocks have 4 little notches on them. And based on those patterns, you can build something up. Then you might try to remove from your analysis any things that are not really important to it. We call that abstraction. Then after that, you come up with a step-by-step process of how you're going to make your logo. That would be your last step, which would be algorithm. All right, so step by step, that's our algorithms. Algorithms, we've talked about them in 3 different ways, at least: plain English, pseudocode, and flowcharts. Today, we're going to be talking about flowcharting. This is kind of a weird example, but you know, maybe you guys can relate to it. The idea of an algorithm, of course, is that we can take those step by step and implement it in whatever method that we've got. Folks, you know, all right. The algorithm that you could make to help you to create the Lego sort of what do you call that? The Lego representative for the games. Mascot, they call that, right? Mascot. Yeah. So the Lego mascot. So the steps that you would do that with, you could give that to people in the Arabic language. You could give it to them in Chinese. You could give it to them in English or French or German, and they should be able to still do that, right? It's not dependent on any particular language. Now, that's the same with our idea of pseudocode, isn't it? We could give the instructions in pseudocode, then somebody could write that in a different programming language. So hopefully there's some metaphors there that strike some kind of similarity with you. So we've talked about algorithms before, and I've already mentioned this to you, right? Plain English, pseudocode, and flowcharts are 3 different ways of us representing an algorithm. When we want to create a Lego, or if we ever are building something from IKEA, then we will follow a step-by-step process. And we talked about the IKEA sort of, would you call those algorithms? Yeah, they're step-by-step instructions that we get from IKEA. They're very useful. And the good idea in them, I think, is that they are language independent. That is, it doesn't matter what language that you read or write in, you can pick up a Lego sort of instruction set and you can make put together the Lego things, because it doesn't actually use written language, right? It just uses step by step and lots of pictures, and everybody can read pictures. So that works pretty good. All right, so we're going this one here about converting units. So here's some examples of different algorithms that you might use. Converting units, that's actually going to be in the tutorial. You're going to have to write a little algorithm for how you would convert from Celsius to Fahrenheit. And as you probably know, almost all the world uses Celsius. There is one big country that uses Fahrenheit. And so, yeah, if you wanted to sort of go there, you might see that their temperatures are kind of weird, right? You know, so if you said it's 32 degrees, you might think, well, that's nice and hot. I could go for a swim, right? But if you're in the United States, 32 degrees, you probably wouldn't want to go for a swim, because that's the temperature that water freezes at. So whereas here it's kind of hot, right? So yeah, so we could use that kind of conversion. Is kind of easy to do, right? 32 degrees plus 5/9 or something like that. It would be easy to write a little computer program that you'd put in the number, which would be the Celsius number, and it would give you the Fahrenheit number, or the other way around. Computing an average grade, I think we can do that. Computing any average is fairly simple. I keep getting a chat here. What's that? Good morning. Oh, okay. Good morning, Frank. It's we add up the totals and we take a count, and then you take the total and divide by the count. There's your average. Doesn't matter what your average is. That's pretty easy. Sorting lists. Now, this is where it really gets interesting. And I think I mentioned this in a previous lecture. We talked very briefly about this concept of efficiency and the big O, which this course is not about efficiency and the big O, but there was a note there about efficiency, so I thought I'd mention that. But it comes with when we go to sort things, that there's many different algorithms that we can use to sort things. And computer science students generally do a little bit of analysis, at least, on which ways are most efficient in sorting things. So that might be interesting to you. Likewise, searching. There's more than one way to search for things. And we'll see. I think we're going to do sorts, and probably with many computer languages that you might use, like Python, they come with libraries. And so those libraries have utilities in them. For example, sorting and searching, so that you don't even have to even write an algorithm to do it, because you just invoke the function that they've already got for you. So it's nice to know, but if you didn't want to bother yourself with it, you could easily write computer programs and just use the sorts that are in the libraries. Finding a word, so that's the search as well. Greatest common divisor of two integers, Euclid's algorithm. Maybe we can have a look at that a bit later too. Okay, so let's have a look at a flowchart. Hopefully some of these symbols now mean something to you. Let's see. So here's just a little definition of a flowchart. Flowchart could be used to represent an algorithm. Important thing in the flowchart is that we have symbols, and those symbols are really shapes, and we usually label them, but each of those shapes has a specific meaning. And yeah, flowcharts might be broken down to be very intricate. So you have to be careful when you're using flowcharts, I suppose, to try and hit a balance between too much abstraction and not enough abstraction, I guess you could say. As it says here, flowcharts are often used in business as well as in IT. We use them in IT to represent graphically what we're thinking in our solution of a problem. Business also uses it as a way for people to see very quickly what a process is. So let's have a look at one here. This is you going to university, I suppose, depending on what time you woke up. You know, how am I going to get there? If it's before 7 o'clock, maybe you can take we call it subway here, the metro. Now, I guess this decision would be based on time, right? So you would know that, well, look, if it's before 7 o'clock, I can catch that metro and I'll get there in time. But after 7 o'clock, I don't really have time to get there unless I use some other way of going, which would be like a taxi. All right, so the symbols, we've got this oval symbol. We use those for our start and stop, or start and end. Also, I've referred to them as connectors because you can use them to say, go to the next page, or you can use them to say, continued from the last page. The square edged, they represent processes, and the diamond represents a decision box. And we see the not square edged, but rectangular, that's going to be for input or output, in this case, input. Output, sometimes we have some other different symbols depending on how we output it. Okay. And there's some nice definitions of those, right? So I've called that start and stop. I've also referred to it as a connector because you can use it to connect to another page. A process, see the nice square edges. We've got a special process too, where we'll put a line down the sides, and that'll mean that it's a function. I think that comes up later in this lesson. Decision, diamond. So the thing about the diamond decision, it's going to have one arrow going into it and two arrows coming out. Input, output, we see the quadrilateral, but it doesn't have square edges. Direction of the flow with an arrow. I think we've discussed all of those there so far, right? So here's another flow chart. Let's have a look and see if we can see how this goes. Now, very important in programming is we have this concept of branching. Branching means that we can come to a particular point in a program process and we can do one thing or another. We don't have to do both, right? There is some choice in the programming processing, which is going to be determined by some condition. And so that's represented by the diamond. And so we see our diamond there. So what do we have happening here? The square edges, there's a process. Greet the customer. Hello. The customer gives us some information. In this case, the customer is going to show us their ITRAS status. We're going to look at that and see if it's green. So this is why the decision box there has the question green. And so that's what is, if you could look at, you could write this in pseudocode or write it in a computer program, which would say something like, if ITRAS is green, then welcome customer in. That would be the then part would be the yes. If ITRAS is green, then welcome customer. Else, that would be the no. Apologize to customer. And that's why here these are look like input outputs, because that's kind of like an output. Apologize to customer. Say, sorry, you can't come in. Have a nice time at home. All right. Now, I mentioned to you that you could have a process, which is a special process that would be like a function. So a function is going to be like, we took a whole, it's a process we've recognized as a pattern. So we want to repeat that process. So we've written a little program for it, and we set it aside, and we can just recall it anytime we want. This would be a function, I guess. So there's going to be more than one step in there. So there's going to be multiple steps, but every time we place a phone call, we do it the same way, right? There's a few different things that we do, but we do all those things the same way. So we can just write one little process that will do that. So that's why we draw the parallel lines on the edge, representing that this is a function. Then we got a decision. So even though it doesn't say it in a question, we know that just because we have a diamond there with two possible outputs, one is labeled as no, so the other one should have been labeled yes. It wasn't, but I guess we get the idea. So what this means is the person home? So your place, this is the sort of the socially awkward loner dude from, I don't know if you guys ever watched that TV series, The Big Bang Theory. Anyways, it's a bunch of people about your age who are, and maybe a little, and they live together. And one of them, he's you know, really, really smart mathematician guy, but not great social skills, right? So, I mean, like, he's got no friends, basically. And so this is about him sort of trying to make some friends. So he'll call up somebody, would you like to share a meal? So if they're home, then you've got some input. Would you like to share a meal? And then they'll make some response, right? They'll either say yes or no. If they say yes, then we've got a function here, a little process that we do. This is more than one thing happening, right? In dining together, you'd recognize that. Dining together, we have to sort of agree to meet. We'd have to go somewhere, and then we'd have to get some food. Then we have to sit down and talk and stuff. Dining together is a lot of stuff going on there, right? And that's why we've represented it as a whole different function, right? So if they said yes, then we'll dine together, and then we'll begin a friendship. Whew, that would be awesome, right? But more likely they're going to say no. And so then we'll ask them, well, would you like to have a coffee? Basically, I think we could replace coffee with hot beverage. And maybe they're going to say yes, or maybe they're going to say no. If they say no, would you like to sort of play volleyball or something, right? And then they're going to probably say no. And eventually we'll just whatever. But at any point, if they say yes, then we can probably meet down here and have a friendship. For socially awkward guy who still has a bit of assertiveness, I guess you'd say. Yeah. He's socially awkward, but not so socially awkward that he doesn't care to have friends. All right. All right. So here's a simple flow chart. It's like not so great. And you guys have started on code.org, right? So you've seen that you can take blocks of code and you can put them together, right? So you could take these as blocks of code in code.org, right? And just put them together, and you could make yourself a little program. You could do that, you know. So you could say, what is your grade? What is your grade? What is your grade? And then you could do a thing that would average them, and then you could show them overall. You could do that in code.org. So this program, what it does is it takes three inputs. Now, each of those inputs is going to be in the range of 0 to 100. When they're added together, they're going to be divided by 3. That'll be an average. So that'll have to be a float because of the division by 3. And then we can print it out. Now, as it says here, the colors are nice, but that's just so that we can look at it and feel that it's beautiful, right? It's nothing to do with the actual program, but it's nice. And so what we are doing here is we're saying, well, there's a little bit more to it than that. We're going to have an assignment weight. So for example, and I guess that's a little bit more realistic, because a test is not worth the same as an assignment. It's not worth the same as what's the other thing there? A quiz. And so what do we see? Assignments 20%, the quiz is 30%, and test is 50%. So we're going to take their grade, we're going to multiply it by these weighting factors, and then we add it together. You know, then you wouldn't have to do the average, because built into the thing is these weighting factors. You wouldn't have to do the average, because if you add those up, they add up to 100, and there's your thing. So that's another way, and this is probably, I would say, more precise or more realistic. You wouldn't just take the average of a test, a assignment, and a quiz and say that's your grade. You'd do something like this. You'd say, well, actually, test is worth more than a quiz, so we're going to have to put more of a percent to it. Because what the other thing was doing was effectively multiplying each of them by 1/3, which is 0.33. So effectively multiplying them all by 33%. So if we just took the 3 numbers and divided them by 3, it'd be like saying, okay, a quiz is worth 33%, assignment's worth 33%, a test worth 33%. But we've decided that's not actually the case. A test is worth more, so we're going to multiply them that way. Maybe we'll look at that. All right, so what you're supposed to do now is you're supposed to draw a flow chart step by step for course syllabus sheet. Okay, so look, your course syllabus sheet, if you wanted to know how to get it, if you went to the home, or content would probably be the easiest. If you went to the home content and then you click down here on course general, there were 2 ways. You'd find the course syllabus there. I think that's what they mean by the information sheet. So that's one way you could do it, or you could go to the table of contents and you could find it there, right? There it is in the table of contents, right? Right under at the first thing. Or you could go to the course home and you could go looking for it there, which would be a really not efficient way of doing it, but you could find it that way. If you went, maybe you could, well, you could search for it here. I don't know. I don't know even what you'd search for. That's the thing, you know, what kind of index have I put on it? You know, what kind of, but you might find that there usually in the first lesson that I ever give, I give a link to the course syllabus. So you could do that, go and search for the first lesson. You could just go to content and find it in the index, or you could, yeah, go to the table of contents. All right, so how would you write a flow chart for that? How would you do that? So all flow charts start with a start. You tell me, what would be the first step if you want to find the course outline, course cover sheet, or whatever you want to call it on D2L? Well, you know, let's start from the start. I'm going to say let's log into D2L. And I'm going to say to navigate to the course in question. All right, what next? You tell me now. All right, so at this point, you've logged into D2L and you're here. Then what? Okay, I like that. Go to content. And we see that when I say navigate to content, that means you'll see that there's a content menu at the top. So we just navigate to content. Then what? Course general. Yeah, all right. So then we can, so I would say scan the contents. Is it called table of contents? Oh, yeah, it's not. Scan the index for, what is that? It's called course schedule. There you go. And we find that on the left. All right, and so we're going to navigate to that. That's what you said, right? Or did you mean this one? Oh, course general. Course general. You know what? What we're actually doing is a little bit more complex than this. There's probably some decisions that we're making that we haven't explicitly mentioned, but you know, hey, because, you know, we'd say, you know, do we see it? Yes, we do. Then click on it. You know, we're sort of skipping over a little bit, but that's okay. And now we see it and we can choose it, right? Open link to schedule. Is it called schedule? Outline, whatever. My fingers are all black now. And that would be it. Maybe we'd want to print it out or something, or maybe we just want to end or stop or whatever. Easy peasy. That's what I think you would do. All right. We focus on basic instructions in this course. We do, yeah. All right. So instructions, actions. Do you remember this from last time? That's straight out of a previous lesson, isn't it? When we do algorithms, we want them to be correct. I spent a bit of time just a minute ago talking about efficiency in algorithms. We also want them to be correct. Ah, yes, the irony. I will not copy again. I will not copy again. The student who copied once gets to write copy, I will not copy many, many times. Or gets to go and talk to the dean or something like that, right? We have spoken about these before also. The major, I guess you could say, control constructs, we use that word, control constructs in computing: sequence, repetition, and selection. So selection I've also referred to as our decisions in our flowcharts. Iteration is also used as a word for repetition. So I've already talked about that. That's kind of nice. Repetition, we can do things. See, here we have this problem, right? The student copied something from somewhere else. The teacher was very sort of not wanting to punish the student too much, but said, well, you know, you still need to learn a bit of a lesson. So this would be like grade school, I guess. And so the teacher says, well, you know what, you can write on the board like 100 times, I will not copy stuff. And there's the irony in that, because they're actually copying themselves 100 times. I will not copy stuff. Now, if the student had a computer to help them, they could do that in like, 1.5 seconds, right? I will not copy 100 times or 1,000 times or whatever. And so that's a repetition. Computers are really good at repetition. I mean, so extremely good at repetition. Let's have a look at that in a minute, right? So, I mean, instead of saying, I will not, the computer would just say, okay, I will not once, repeat 100 times. And that is the power of computing. Much, much more efficient than doing something like this. Start stupid punishment, end stupid. Yeah, I totally agree. So why wouldn't we just say, I will not cheat on my assignments, and repeat that many, many times? Have you guys seen a repeat? Have we done a repeat? I don't know. Have we done a repeat? I think we have. Anyway, so at about this time, you will be using the idle IDE, which is a development environment, integrated development environment. So in Python programs, we have, oh, you can't see this, can you? Because the size is too small. I might be able to see that better. Well, maybe that's too big. I can't fit it on the screen. 16, that usually works. All right, so yeah, okay. So we want to repeat the stupid punishment, which is we're going to say print what? I will not copy. So just showing you that Python's really easy to use. Don't know if I've run a Python program for you before, but I will not copy. Well, that's not great. But so, I mean, you could say, oh, well, I'll just repeat that. I'll just copy and paste, right? Copy, paste. I could do that like 10 times, right? Yeah, all right. Well, that's one way you could do it. But I mean, that's not much better than just, typing it out, right? I copied and pasted, but there's a way, way better way of doing it. And that would be our iteration. So what we would do is we would say, okay, we could make it go forever. No, I don't know. Let's just say something like count is equal to 0. Then while count is less than, I don't know, how many times you want to do it? 10 times? Then we're going to do that. Now, this will not stop because we're not updating the count. So we better update the count. Count takes the value of count plus 1. Now we can do that. And so, that's a little bit better. We only had to type, I will not copy once, and it did it that many times. And the thing is, it's so easy to change it now. Instead of doing it 10 times, we could say, oh, well, I'll just do that. Yeah, see how easy that was? I just typed an extra 0 on there. And now I got it going 100 times, right? So this is the power of computing. And I could do it 1,000 times, right? I can just do as many times as I like, right? So, and hardly takes any time at all, right? There's 1,000 times. Now you might not believe me saying that's not 1,000 times. You can see that it's 1,000 times because we're going to print the count. And we'll see what the last print is. Oh, yeah. So now the very naughty student has a very, very quick way of solving their problem, right? It's a little loop, and we can use loops. This is repetition. This is iteration. This is a simple way of doing it in Python. I'm not asking you to write a Python program, but we could do this with a flowchart. We could say, all right, start. And we would say, okay, count takes the value of 0. And then we could say, see, we got a condition in here. The condition is, as long as the number is less than 1,000, we're going to keep going, right? So we're going to say our condition here, count is less than 1,000. This is a condition, so it needs to be a diamond, right? And so if it is true that the count is less than 1,000, then what we're going to have to do is we're going to print. So that's an output, right? I will not copy. It's going to be printed out. And then we're going to, sorry, I'm running out of space here. Let's go up here. Then we're going to add 1 to the count. Count takes the value of count plus 1. And then we, oops. Yeah, all right. The reason why I said oops is because my arrow is kind of getting in the way. Yeah, so that's going to go back to there. So once the count is, and if the, so this is yes, and this is no, and then here we do an end or a stop. So there's our little program. It's a lot easier than writing out, I will not copy 1,000 times, which we could have done. But this is the power of computing. You see how easy that is to do in Python. So as I said, I'm not asking you to write Python programs right now, but please do observe some of the things that we notice in Python. What you might notice there is at the top there, we've got the stuff in red. This is the Python, the idle. I'm running idle dot the IDE, the integrated development environment. The editor there recognizes certain symbols. When it sees a hash symbol, it knows that whatever follows the hash on that line is a comment, and it will not be processed by the interpreter. It also notices some other things like, all right, so if you say something like this, it knows that what you're doing is you're declaring a variable and you're giving it a value. When it sees the word while, it knows that what it's supposed to do now is iteration. And when it sees a colon, it knows that that what follows there is going to be part of this programming structure. And so it indented this for me automatically. I didn't have to do the indent. It did that for me. So that's the IDE. Very nice. Be very careful when you start writing Python programs about your indenting and stuff like that. Don't go doing the indenting. Let Python do it for you. Otherwise, it'll mess up your program. Anyways, that was fun. for me. I don't know about for you guys, but yeah, so we can do that very, very easily in a flow chart, which I showed you. We did it for 1,000. Why would, and so let's do another one. Happy birthday. Okay, so we need a flow chart for that. Can you help me? I mean, I can write the program. What we usually do is we do the flow chart first to make sure that our thinking is right. Sorry, I removed this. You guys good with that? Should have read this in the first place. I wouldn't have to get my hands all black. I don't mind having my hands black, just not with stuff that comes off every time I touch them. All right, so. Oh, good luck. All right, so we need to say happy birthday. So our start is going to be to ask the person their age, right? Going to stop this in a minute. So we're going to ask them their age. I guess that's a process. And their age is going to come in. And that's going to be an input. And then what happens? We're going to print happy birthday as many times as their age. All right, so I think what I'd do there is I'd say, well, we need to have a count. Well, we got age. So we could have another one, which would just be, okay, we could set a count to 0. And we'd look and see, is the count bigger than or equal to age? And that would be a decision. And if it is true, then we're going to stop. End or stop. And if it's false, or then we're going to, or no, then we're going to print I guess that would be an output like that. And then we're going to add 1 to the count. Then when that's done, we're going to check again to see if, sorry about our arrows going everywhere. So that would look, let's do that in idle as well. So new idle. This is a happy birthday program. So it's a good idea when you write an idle program to give some comments to say what's happening. So the first thing we're going to do is we're going to find out their age. Age takes the value of. So when I say age equal, it doesn't mean age equal like in a math equation. It means age takes the value of. What it means is in Python, please set aside a memory variable, call it age. This is going to be some space in the memory, and then assign a value to it, which is going to be the value that's on the right side of that symbol equal. And so how we do that is we do that with an input. But the problem with inputs is inputs can only be text. So this is a prompt. Now the problem is that age is going to, if I leave this like this, the problem is that the age will be saved as a text string. Strings are no good to do mathematics with. And because we want to do mathematics, I have to convert this to an integer. And so we do that here. This is called casting. I've just casted whatever's the person's going to put at their input is going to be converted to a number. All right, so that's all we have to do there. Count takes the value of 0, just like we said there. While count is less than age, then we're going to print what I'll do, just so we can check on it, is we'll also print the count. And so we'll see how many times. And that's it. Oh, well, we better update the count. And if we run that, now, as I said, I'm not asking you to do this. I just want you to see a little bit of Python before I ask you a few weeks from now to start doing it. Or if you want to go home and play with Python, that's fine. But I'm not asking you to do that now, right? That's coming, but I think you should see it, right? And you can see how easy it is to use. Happy birthday. And so you put in your age. Now this is kind of awkward, but you know, let's say it's a 12-year-old. Didn't end. Okay, so I've got a non-ending loop. So what did I do? Did I forget to do the thing? So count equals 1. All right, count plus 1. So that was a typing error, and it made the program not work. So now it works. Now it actually did it 12 times, but the first time it did it count number 0. I'm okay with that. I mean, the other thing here is we probably should have put a space there. And yeah. So you guys, most of you are more older than 12, at least 19. And you might say, well, you know, no, nobody's age is 0. Oh yeah, you could be 0. But that's saying happy birthday 19 times. Now, if you don't like the count of 0, what you could have done is you could have printed count plus 1. And that would make it. So maybe I need to stop that. Run it again. So now it does it 18 times, starting from the first one. So, I mean, hopefully that's, as I said, I'm not asking you to go home and write this Python program, but I hope that you can see how this relates to the flowchart, right? And you can see what's happening here. Input. Okay, this is setting a variable to 0. This is initializing a variable and putting a value in it. Then we've got a loop, our iteration. And this loop is going to continue until this condition is no longer true. This condition will be true as long as count is less than the age. Eventually, the count will become equal to the age because we keep adding 1 to the count. Let me just print. Easy peasy, Japanesey and lemon squeezy, right? I guess that's the end of the lecture. So I'm going to stop there. And thanks, students.